How do you do, ladies and gentlemen? I'm Julius Sumner Miller, and physics is my business. And my special business today is this subject, the transfer of heat energy by convection. Convection. On an earlier program, I talked about conduction. And here I have taken a piece of clothesline and set it afire, so to say, in a burner, and then shut out the flame, so it is giving me a lot of smoke, abundant smoke, and I've got a real smokestack there, as you see. Now, let's look at this mechanism. Here in this chamber is a candle, a lighted candle, and smoke is coming out of here at a vast rate. Fantastic. I think you can see it. Now I'm going to put some covers on, a cover on that chimney, and the smoke is trying to come out here, but not so well. And if I let this stay for a while, I'm sure the candle would go out. Most assuredly it would go out if I covered both. Now, watch. I'm going to take both off. Do you see? Not quite as well as I'd like it, but I'm going to do it again. Watch it now. Watch it. Watch it. Now I'm going to take this one off, this cover. Watch. I assert that the smoke is falling down. Very little of it is coming up. Very little of it. This is a little different. Oh, there it is. Let me do it again. I'm going to fill this stack now. Watch it. Watch it. Now I'm going to take that cover off. Watch it. Yeah, there it is. There it is. So you saw smoke go down, fall down. This is a wonderful thing. I'm going to pose a little problem for you. Here is a house with a smokestack. I say that on some days I see the smoke come out and go up, 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 up. Then there are other days the smoke comes out just out of the chimney and falls down, down, down to the earth. Question, on what kind of day does it do the one, and on what kind of day does it do the other? Well, I'm going to help you a little bit because it's a strange business. It goes up, up, up on a dry day, and it falls down on a damp day. What does this tell us? It tells us that damp air is not as heavy as dry air, and therefore does not provide the buoyant effect necessary to lift the air up, the smoke up. And this is a fantastic thing, to say that wet air is lighter than dry air. It has water vapor in it. Wouldn't you think that it would be heavier? But it is not. Now, while that's smoking, here is another. I have a framework, a closed rectangle of glass with some water in it. I am going to put some food coloring in this corner of the framework. Watch it now. Some food coloring. There it is. And you will see it drift down, diffuse down, gravitate down in a wonderful way. Look at it. Look at it. Look at it coming down. It's coming down. It's coming down. Now I'm going to apply some heat to this tube. Watch it now. You see the coloring, which is heavier than water, drifting down and diffusing. Now I'm going to apply some heat energy here. And I say, color, go back. Color, go back. That's what I command it to do. Oh, it's coming down. It's coming down. But I say it should go back. Watch it now. Watch it. Aha! There, it's going up. It's going up. And it's going to come down here. So I'm going to play the burner, the flame on this side, and I say, coloring, do not come down. Do not, I say do not. Well, it's coming down. Somebody says, oh, you cannot fight nature, Professor. No, I am not fighting nature. I am collaborating with her, and now it is migrating back. There it is, and I could drive it the other way. So we are talking about convection. Convection. The transfer of heat energy by actual transfer of stuff. Remember, in an earlier program, I talked about conduction, which takes place in solid things like metal rods and wooden rods and the like. Now I am talking about convection, which takes place in fluids, because something must flow, and fluids is the generic name for gases and liquids. So we have this strange business of convection. Another illustration of it, an imaginary experiment. Imagine that I am sitting here smoking a cigarette, which I don't do because I don't smoke. So this is the real part of the experiment. And here I have a reading lamp throwing some light on a physics book. And the lamp is lighted. Question: where does the smoke from my cigarette go? Up here? No, strangely enough, it does not go up here. It goes up under the lamp and out from under the shade. Why? Because the heat of the lamp gives rise to a reduction in the density of the air, and a convection current is set up. Now, regarding this convection, I would remind you, a massive piece of business, because when we have convection on large scale in nature, what do we have? Gales and hurricanes and tornadoes. Fantastic energy in the moving air. And yet, consider the moving air. I tried to grab it. As I am led to say, there ain't nothing there. But oh, it is amazing. There are 3 times 10, listen to this, 3 times 10 to the 19 molecules of gas in a cubic centimeter of air. Incredible. An illustration of how big this number is. Supposing you and I and a million other people went to the ocean side and picked up that many grains of sand, and we piled them all up in a pile. How big a pile do you think we'd have? We'd have a pile that is 1 mile wide, 1 mile long, and 1 mile deep. A cubic mile of sand. And as I am given to say further, so you get an idea how big this number is. You know, I'm talking about there ain't nothing in air. 3 times 10 to the 19 grains of sand. Supposing you could count 10 per second. What is it over 10? What is it over 10? How long do you think it would take to count that many grains of sand? Answer: 100,000 million years. And I say, ain't that something? And there is nothing here to grab. Incredible.